Okay, in this video, we will look at example 12.15 and then really briefly 12.16, which is short. 12.14 has been skipped. That is your assignment to work on in class or at home. Have it done um, by whatever due date or time is on Schoology. At the time of recording this video, I don't remember off the top of my head what that due time is going to be. Um, but you'll be doing that on your own. It is similar to the problem we're about to do, whereas 12.14 is a confidence interval. This example is going to be a significance test. So there will be differences in the calculation portion, but you could refer to the previous video for confidence interval if you need help with that. A lot of the rest of it's the same. The intro information that you write out, the conditions are the same. Just be careful of the math and a couple other details. And I'm choosing to do this particular example in the video because I want to show you how to get Desmos to run the full analysis for you. Previous examples had a regression output given, meaning you didn't have to really do much math at all. You just had to use numbers provided, maybe with one or two exceptions. Here we have to do all of it. All right, we've got the See an Enemy Self-Defense Academy sensei wondering if students who attend more sessions are likely to give better ratings of their experience. Okay, so our explanatory variable is number of sessions attended. The response is a quantitative rating that students gave. So we're going to start by putting together the regression model. Okay. So step one, we have to input all this into Desmos. I'm going to flip over now and start working on that. I do not have this memorized, so I'm going to have to flip back and forth a couple times. But Desmos, starting with the plus icon, we're actually going to start with a table today. Got to get a table of the X and Y. Okay, so clicking into table, it gets us started. We can start inputting the X's. 3, 4, 5, X, 6, and another 6. Couple of 7s. 8, 9, 9. Once you've got your numbers in there, make sure you double check. A single error is going to throw off all of our analysis. That's what I'm doing right now as I flip. I'm just checking my numbers. I think it looks okay. All right, for the Y data, 5, 2, 7, 5, 7, 8, 9, 5, 7, 7. All right, I think that's looking pretty good as well. Okay, I'm going to pretty much show you all the stuff here and now, and then we can start filling in details on the write-up, so I don't have to flip back and forth as much. But one thing you do notice right away, as we plug in these points, we do have the actual scatter plot provided. You might have to adjust your window for Desmos to get the proper view of it. But there's a scatter plot. Okay. If you have to sketch graphs, which you would have to sketch if they're not provided, you're going to sketch this, which as you can see, I have roughly sketched it out already on my answers here. Okay. So that's my scatter plot. Next up, we're going to put some regression on this thing. Okay. I'm going to click on, there's a little icon to the left of my table. It looks like a little mini baby scatter plot with a regression line. It says add regression. We're going to click that. And so quick, so easy, so breezy. We have our regression line through the model as well. And just below that, you have all the numbers you need. Here's your y hat equation. I really wish that Desmos would put a hat on this thing as a reminder to you, because when you write this down on your page, it's got to be y hat. But they do give you the regression equation, the r squared, the r. Okay. It also gives us the opportunity to plot the residuals, which we're going to need to do. So I'm going to click that button for plot. It can be a little confusing because now you have the residuals right next to a scatter plot, but you can go back up to your Y column and you could click on the Y1 icon to turn that off if it's bothering you. Okay. The residuals will be centered around the horizontal axis. And it, of course, generated the whole list of residuals as well. Really quick, really nice to have. Okay. So already we've seen two out of the three graphs we need to sketch. We had our original scatter plot. We've got the residual plot. The other graph that we would need is a box plot of residuals. So let me go ahead and show you how to set that up. I'm going to open up a new cell off to the left. Ever so simple. We're just going to type the word box plot, parentheses, and now you're going to feed it the name of the list for which we want a box plot. And Desmos has called mine E sub 1. I'm sure maybe there's a way to change that, but I don't feel the need to change it right now. I'll just go with it. Um, Box plot E1, I just typed that in. It gave me the subscript automatically. And sure enough, we see our box plot, which again, you can zoom around as necessary. If you click onto this thing, is it going to show me key numbers? Maybe not, but that's okay. I don't actually have to report a five-number summary. I just need to show a little baby number line, probably from -4 to 4, with the approximate minimum Q1, median, Q3, and max. Okay, so yeah, all my graphs real quick, real easy. I would not sketch them all as one big blob like it shows up on Desmos, but if I flip over, you can see where I have sketched out all three of those plots the way I would want you to do it. Okay. So I don't know. To me, this feels a lot quicker and easier than doing it on a calculator. Anyhow, onwards to the actual analysis here. If you don't mind, I'm going to get rid of my box plot altogether for now. Bye bye. Okay. Um, to create a inference procedure off of your regression specifically, we're going to look at this area below our tables. I see that we are currently working with linear regression. There are a lot of types of regressions. We're not going to look at those in this course. Just to the right, though, I see three dots, regression options. Let's go ahead and click that. And it shows us the general model structure. We are going to export this as a custom regression. Click, and it's done. Okay. Now they're speaking about your your slope and your intercept more generally. They do continue to show us the actual numbers from our data, but they speak to them more generally, referring to M and B. And to run a test on either M or B, we only care about M. We're going to go to another box and we want to use a t-test. So I'm going to type t-test. That's double T in the front. Parentheses, M. That's how easy this is. Okay. Now, if I wanted to run a confidence interval, I could open that tab. I could take a look at what they've given me. I could adjust the confidence level as necessary. Okay, I see some extra stats about point estimate, standard error for slope, things like that, which we will maybe need that number for our write-up. But I'm not actually doing a confidence interval. Just wanted to show you that it's there. Let's close that up and open up significance tests. Okay. Right away, I see a lot of useful things. I got my DF. I've got my p-value. That p-value changes depending on if I want a left or right side interval. We actually want a right side interval in this prompt. So make sure you click accordingly. Okay. But I can see the actual p-value that we'll be using. If I click my three dots, um, Actually, hold on. Yeah, okay. I'm kind of realizing this as we go. The significance test does not show you the standard deviation we need, which is a bit troubling, but that's okay because it did show up under the confidence interval tab. And this is the very same number, 0.2369, um, that we're going to be using. So it's a bit hidden, but it is there. Okay. Maybe it is down here and I missed it, in which case I'm sure one of you will tell me. But they give us our t statistic. We're going to be using that number for our work. Obviously, the p-value we talked about. It's got everything that we need to do the full write-up. Okay. Now, this is taking a lot longer than it would take you because I'm talking as I go. But as you do this in real time for a homework problem or, a test, it is really, really quick and convenient. And I love that they give you the graphs as well. Okay. So we're going to take all this information, move it over to our write-up. Here's me flipping maybe for the last time. We will see. And we're going to speak to the write-up itself now, starting with phase one. This is where you give some intro definitions. There's more going on here than usual in chapter 12. We're going to define our x and our y. Hopefully that's obvious to you to spell out what x and y are. X is the number of self-defense sessions, y is the score, the rating. In addition to that, we better define the parameter that we're testing. And we use this capital beta symbol for a population slope of a population regression line. So we're going to define that here. And it would also be silly to do this analysis without actually providing the LSRL that we're basing it off of. So then we provide the sample LSRL, put your hat, Y hat, and we are pulling numbers uh, directly from Desmos here. All right. Hypotheses. We typically always start with a null saying that the slope is zero. We start by assuming there is not a useful relationship going on between x and y, and then maybe we'll see if there's evidence otherwise. My alternate today is a greater than because of the word that's underlined in the question. Do the data provide evidence that students who attend more sessions give better ratings? Okay, as opposed to less ratings, as opposed to is there a relationship between the ratings? So here it's a greater than. We're going to use alpha of 0.05. Okay. Um, what procedure? Well, it's a t-test. I would call it a t-test for slope of an LSRL. As far as our rationale, similar to what it's always been. We're using t because we don't have a population deviation for slope. We're going to test a claim about slope. Deviation is not known. T-test for slope. Okay. Moving on to the conditions. We already looked at all the graphs. At some point, we copy them into our work for reference. Okay. Linear condition. We start with the scatter plot. Give me form, direction, strength. I've already defined y and x, so throughout here I can just refer to things as y and x. Maybe a note about the residual plot, but I'm not going to require that. I do have these out of order compared to usual. Can't remember why I did that. But our independent condition is actually a 10% check here. 10n. Sample size is 12. Got 12 people measured. We just measured two different variables. So we do 10 times 12. Do we think this academy has more than 120 students? I don't know, but seems safe to assume, or you can proceed with caution. Normality check. This is where we look to the box plot or histogram. In this case, we've got a box plot of residuals. It looks okay to me. No extreme skew, no outliers. So we're good to go there. Equal condition, you can call it equal variance. I will also take equal standard deviation. Either one's fine. We go back to the residual plot. Talk to me about whether we have consistently random scatter around the horizontal axis, which again, I think we look okay. It's a small sample size. I don't know that there's enough of a pattern here to claim confidently there's a pattern. All right, which one did I not talk about? Random, of course. Last but definitely not least, we do have a random sample in the prompt, I believe it said. Yes, good. So make sure you say so. Again, the order doesn't matter. Maybe you stick with the liner acronym. As long as you have all five is fine. All right, phase four, the math. This is real quick and painless since the numbers have been crunched already. Give me the DF. N minus 2 would be 10. Okay, test statistic. It's the same structure of a formula we've seen in previous chapters. It's still modeled off of z-scores. We are going to continue to take a sample observation minus the hypothesized value of that number divided by a relevant standard deviation. This test is all about slope, so it's going to be your sample slope. Again, that number is pulled from the LSRL minus the hypothesized slope, which is 0. The relevant standard deviation is the SEB. This is the number that scares me a little bit because you had to hunt around for it in Desmos. It was living under the confidence interval tab, but it was there, and we do need to write it down for our work. Okay. You could do this math manually, but you don't need to. Again, the T statistic also showed up in Desmos. Just a quick reminder where these numbers are. Confidence interval, 3 buttons. Here's the standard error that I want. Close that. Significance test, 3 buttons. There's that T test statistic. Here's the p-value. So everything is right there. So it's 1.329. Our p-value then is the probability that T could be at least that big, which is 0.1067. In this case, since our p-value small but not small enough, we fail to reject the null. I would not write anything about in favor of the alternate. We are not going in favor of the alternate. Please do not mislead a grader. But I do want to give some context. One thing you could say, we do not have evidence of a useful linear relationship between the two variables. Write them out. Okay, or alternatively, you say we lack evidence um, that the students with more sessions give better ratings. I would take either one of these. I don't need both. Okay, so there's your write-up. Your homework is the 1214. It's going to have some differences in parts of it, but use your best judgment. We'll check answers when I'm back. Okay. And real quickly, I do want to talk 1216. This example here is just by way reminder that we can use a confidence interval to arrive at a conclusion if you had a two-sided alternate hypothesis. A two-sided hypothesis is basically just saying we think there is a useful relationship between our variables. We don't necessarily know if there's a positive or negative trend, but we think the slope is going to be non-zero. And of course, if you have a confidence interval, you're just checking whether zero's in there or not. So here we have a sample of 11 tourists, 95% interval for slope. Both bounds are negative. Zero's not in there. So we are pretty darn confident the true slope is not zero, which means there is, in fact, a useful relationship where we can use X to predict Y. So we reject the null in favor of the alternate. There is a relationship between hours in the casino and money gained. Looks like it's a negative relationship. As hours increases, money gained tends to decrease. So maybe make a comment about what you're seeing there as well. All right. I kind of forgot 1217 was squeezed in here at the end, and it's another short one. So let's go ahead and do that one as well. Okay. Um, this is here just to remind you that when we do have these computer outputs to work with, very, very nice, very helpful. Okay. This T column, by the way, is the T statistic for your significance test. I would not use this number in a confidence interval, but I can pull this number right here that I'm hovering over uh, for a significance test, as you can see in my work. But the larger issue is to remind you that these outputs generally provide a p-value in the p column, assuming a two-sided test. If you have a two-sided test, great. You can pull this number directly and show it. But if you have a one-sided test, which we do here, we want evidence that score decreases as drive distance increases. That's a negative slope relationship. So slope less than zero. Make sure to modify this number. It's easy to do. We just cut it in half to turn two-sided back to one-sided. But you can see I pulled both of these numbers in my work. I had to put in the modification on my own to get the proper p-value. So just be reading carefully for that. Okay? And that concludes the video. Shoot me an email if you have questions, or I'll see you when I get back. Thank you.